Welcome to our exploration of Java Enterprise Edition, or Java EE. This is a collection of Java APIs designed for developing and deploying enterprise Java applications. These applications are software programs that operate on servers, tailored to solve the challenges faced by businesses and organizations. Java EE simplifies the creation of robust, scalable, and secure enterprise applications by providing a platform for developing distributed multi-tier applications. It defines a set of services, APIs, and protocols essential for developing multi-tiered, web-based applications. Typically, Java EE applications run in application servers, which not only provide the runtime environment but also support the Java EE APIs. With its rich set of features, including web services support, component-based architecture, and object relational mapping, Java EE builds on the Java Platform, Standard Edition, Java SE, enhancing it with capabilities suited for enterprise-level applications. Over the years, Java EE has evolved continuously to meet the changing demands of enterprise application development. Now, let's delve into Session Beans, a fundamental component of the Java EE architecture. Session Beans are Java objects that execute business logic on the server side. Acting as intermediaries, they facilitate communication between client applications and the underlying data sources, business logic, and other enterprise resources. By encapsulating business logic, Session Beans provide a structured way for clients to interact with the application, ensuring a clear separation between client and server functionalities. They manage client requests, execute business logic, and handle data access efficiently. Managed by the EJB container, Session Beans benefit from services such as transaction management, security, and concurrency control. Java EE categorizes Session Beans into two main types, stateful and stateless, with the choice dependent on the application's specific needs. Stateful Session Beans maintain a conversational state with the client, whereas stateless Session Beans do not. Focusing on stateful Session Beans, these are designed to maintain a conversational state with the client. This means they retain information about the client's interactions across multiple requests. Each user interacts with their own instance of a stateful Session Bean, created at the first point of interaction. The state of these beans is held in the instance variables and is preserved throughout the client requests, accessible only to the client who initiated the bean instance. Stateful Session Beans are particularly useful for tasks that require a series of interactions with the client. For instance, in online shopping carts, a stateful Session Bean might store items a user adds during a shopping session, thus supporting complex interactive workflows like user authentication sessions and more. On the other hand, stateless Session Beans do not maintain any conversational state with the client. Each client request is treated independently, with no information retained between requests. These beans are not tied to any specific client and can efficiently serve multiple clients concurrently. Stateless Session Beans are perfect for operations that are atomic and do not require a user-specific state, making them ideal for tasks that are self-contained and do not depend on previous interactions. Common use cases include processing credit card payments, currency conversion, and order submissions, where a stateless Session Bean can handle a credit card payment without needing to remember any previous interactions with the client. In Section 5, we delve into stateful versus stateless, selecting the right bean. Choosing between stateful and stateless Session Beans depends on the specific needs of the application. Stateful beans are appropriate when the application requires maintaining a conversational state with the client, while stateless beans are suitable for operations that are independent of previous interactions. Stateful Session Beans are more resource-intensive than stateless beans because they require the server to maintain a separate bean instance for each client. Conversely, stateless beans are more efficient because they can be shared among multiple clients. When designing an application, it's essential to carefully analyze the requirements and determine whether maintaining a conversational state is necessary. If the application requires user-specific data to be preserved across multiple requests, then stateful beans are the appropriate choice. If the operations are atomic and do not require maintaining any state, then stateless beans are the preferred option. In Section 6, we explore real-world applications. Stateful and stateless session beans are widely used in enterprise applications across various industries. They provide a robust and scalable way to implement business logic and manage data access. Stateful session beans are commonly used in applications that require maintaining user-specific information, such as e-commerce websites, online banking systems, and personalized dashboards. Stateless session beans are often used for back-end processes that do not require maintaining any state, such as processing orders, sending emails, and calculating financial data. The choice between stateful and stateless beans impacts the architecture and performance of the application. Understanding the strengths and weaknesses of each type of bean is crucial for designing efficient and scalable enterprise applications. Session beans offer several benefits for developing enterprise applications. They provide a structured approach to implementing business logic, simplify data access, and enhance the maintainability of the application. Session beans promote modularity by encapsulating business logic into reusable components. They improve code organization and make it easier to maintain and update the application. Session beans also enhance security by providing a layer of abstraction between the client and the underlying data sources. The EJB container manages the lifecycle of session beans, providing services such as transaction management, security, and concurrency control. This relieves developers from having to implement these functionalities themselves, allowing them to focus on the business logic. While session beans offer numerous benefits, there are also challenges and considerations to keep in mind when working with them. Stateful session beans in particular can pose challenges related to scalability and state management. Stateful session beans consume more server resources compared to stateless beans, as each client interaction requires a dedicated bean instance. This can lead to performance issues if the number of concurrent users is high. Careful design and optimization are necessary to ensure the scalability of applications that heavily rely on stateful session beans. Another consideration is the management of the state in stateful session beans. Developers need to ensure that the state is properly initialized, updated, and cleaned up to avoid memory leaks and inconsistent data. Stateless session beans, while simpler to manage, require careful consideration to maintain data consistency and transactional integrity. The world of enterprise Java development is constantly evolving, and session beans continue to play a crucial role in modern applications. Future trends in session beans focus on improving their scalability, efficiency, and integration with cloud-native architectures. Microservices architecture, which emphasizes breaking down applications into smaller independent services, is gaining traction in enterprise application development. Session beans can be effectively utilized in a microservices environment, with each microservice encapsulating a specific business capability. Cloud-native development, which leverages cloud platforms for application deployment and scaling, presents new opportunities for session beans. Cloud providers offer managed services for deploying and managing Java EE applications, simplifying the development and deployment process. Understanding the distinctions between stateful and stateless session beans is crucial for developing robust, scalable, and secure Java EE applications. Stateful beans excel in maintaining conversational state, while stateless beans provide efficiency for independent operations. Choosing the right bean type depends on the specific needs of the application, considering factors such as state management, resource utilization, and scalability requirements. Session beans offer numerous benefits, including modularity, security, and simplified data access. They continue to be a fundamental part of enterprise Java development, adapting to new trends such as microservices and cloud-native architectures. By mastering the concepts and best practices of session beans, developers can create efficient and reliable enterprise applications that meet the evolving demands of the business world.